Hello, I'm Morton and today we will make Conway's Game of Life in Python and Pygame. We will also use NumPy. So let's just get started. I am going to create main.py. Wait, what? Why is this? So first of all, let's just import Pygame as PG. Import system and also import NumPy as NP. Let's just write our first class, map manager. Self dot rules equals just this, and then this one will be 3 1 0 1 2 3 4 5 6 7 8, and I will just need these. Basically the rules are a dictionary containing like the neighbors that you must have in order for an action to happen. For example, if you're alive and you have like one of these amount of neighbors, then you will die, and if you are dead and you have this many neighbors, then you will be born. I will also create a map numpy dot zeros, and then after that it will be oh wait, I forgot to add the constants, right? Yeah, hold on. So I'm just going to define the constants in here. The offset is going to be 1. The map size, the map width and the map height is going to be 30 and 50. And the screen size is going to be, well, screen width and screen height, which are going to be map width multiplied by rect size plus offsets, and then the same for map height as well. And well, yeah, that's pretty much it. I'm also going to init pygame.font, because I'm going to use this font file in here. um, and then I'm going to create a function to get a value. Basically, it will try to access the value, and if it cannot, then if it just return false. Return map y and then x. If it cannot, then if it just return false, as I said. Let's just create the update function in here. We will create a new numpy array every time we will update the map. This is because it's, hold on, map height, map width, dimension type equals bool. This will make it like boolean, and since it's 0, zeros will be automatically converted to falses, and then the same for here. The reason that we are creating a new map every single time we're updating is that if you were to change the map while you are like checking the neighbors, then it wouldn't work. So you have to create a new array, new map, fill it with zeros, and like check every cell, every such neighbor, and then like determine their new state for the next frame, put it inside the new cell, and then you say the old map equals new cells. You have to do that. So y equals 0 for line in self.map, x equals 0 for tile in line. I'm going to put near tiles. This is just contain like neighboring tiles in here. Self dot get x -1, y +1, and then if you just let's just get that, copy that and copy that. So now let's just check if it's working. -1, +1, 0, +1, +1, +1, -1, 0, empty, because this is our current tile, +1 and then empty, -1, -1, 0, -1, +1 and then -1. Okay, so this is correct. Then we will say numpy.sum and then give near tiles. This will give us our neighbor count in here. And then when we get our neighbor count, we will put it through a function. And the function will be apply result function. Self count x and y. Basically, it will like take the count, and then based on the rules defined in here, it will determine the next state. So we will say if f.map y x equals false, then we'll say for I in self.rules I, if count equals I, then we'll say return true. So this means that no, not return true, it will be false, right? Ah, wait, no, this is supposed to be 1. I wrote it wrong way. Yeah, and then it's going to be true. Yeah, and if it cannot find it, then it will just return false. And then we'll say else. So this means that the cell is alive. If the cell is alive, then we'll say for I in self.rules die. If count equals I, then we'll say turn false. Or if it cannot, if count cannot, if it cannot like return false, if this never happens, then it will just return true. So that's done as well. And then we'll say result equals self dot apply results. We will give count in here, x and y in here, and then we will say new cells y and x equals results. So yeah, that's that. And then after we've done it for like every tile in here, hold on, wait, plus equals 1, y plus equals 1, yeah, this is correct. Then we will say f.map equals new cells, right? Yeah. And then we will say def render help and also screen y equals 0 for line in self.map, x equals 0 for tile in line, if tile equals true. So if it is true, then we will just draw a white rectangle. Rectangle will be um, move move value is going to be direct size plus offset. This just determine how much it will go. So we'll just multiply this by move value, and then also for the y-axis as well, and then we'll just give direct size for the side of direct. Um, that's supposed to be surface. Yeah, and then we will just in here the cell is dead, so we will change this will with a dark gray color. And well, yeah, that's pretty much it for the map manager. I want to go over it and see if it's working. Give cells equals stats y x count false, um false to false, false. Yeah, this seems correct to me. So let's just create the app itself. Dot screen equals pygame dot display dot set mode. Size is going to be screen size. Dot clock equals pygame dot time dot clock. Dot time equals 0. Self dot what was it? Self dot post equals true. Self dot font equals pygame dot font dot font. The font file is this. I'm going to just get the name. And health dot delta time counter equals 0. Self dot well, let's call it UFPS. Self dot wanted delta time equals 1000 divided by self.ufps. Basically, we don't want it to update it every single frame. We will just like we will update it every like 10 frames in like a 60 frame. We can change this value however we want. So I'm going to create the start game thing. Map manager equals map manager. So we'll create an instance of it. Def run self it dot start game while true, and then in here we will say pygame dot display dot type caption string dot block dot get fps. We will get the fps and then convert it to a string and then set the display caption. Dot screen dot fill, it will be black. Dot time equals pygame dot time start dot clock dot tick. We will make it 60. We will try to go 60 fps. Self dot delta time counter plus equals self dot delta time for event in pygame not event dot get. We will get event in here. Event dot type equals pygame dot tweet. Yeah. Not exit. If the type is key down, and if the key is also pygame dot key space, then we will say that self.post equals not self.post. Since this is a boolean, when it's true, it will make it false. When it's false, it will make it true. So yeah, and then after that we will say um, self dot map manager dot render self dot screen, and then we will say if self dot paused, we will say self dot screen dot lit self dot font dot render. It will just say paused in big red text. In theory this is going to be false because it's like pixel art. Um, going to be red, and the position is going to be 0, 0. And if it's not paused, so the game is running, then we will say if health dot delta counter is bigger or equal to self dot wanted delta time, then we will say self dot delta counter equals 0, and then self dot map manager dot update. And in this function we will say pygame dot play dot update, and that's pretty much it. We also have to add uh, mouse event handling. If pygame dot mouse dot get pressed, if you press the left mouse button, then we will say try and accept this, because if the mouse is like not if the mouse is outside of the map, then it cannot like get that element. So in order to like make the game still run even though it encountered a error, we will use try and accept. And in here we will say, for that we will say mouse position equals pygame dot mouse dot get position. We'll also say that wait, oh wait, we don't say that. Yeah. Map dot map manager dot map, and then in here we'll say mpos 1 integer divided by rect size plus offset, and then the same thing for the x-axis as well. So I'm going to change that with that, and then it will be 1. If it encounters an error, it will just do nothing, so it will pass. Wait, I can just pick this and then paste it in here. Make this fun, make this RMB, and then add both of these in here. So now let's test if I've done everything correctly. Wait, wait. It's not working for some reason. I think something is fine. Hold on, wait. Oh, okay, okay, okay. I realized that I forgot. This is just a class. I have to like put in this. Sorry, hit the app instance and then app.run. Yeah, now it will work. And well, it kinda did, but just drawing this single cube. Now why is that? Yeah, because it's not increasing the y or x values. So now I think it should work. Yeah. And as you can see, we've created Conway's Game of Life. Isn't that cool? Like, I really like it. For example, there's a glider thing in here. It just moves diagonally like this. If you liked it, don't forget to like subscribe and like the video. I hope you enjoyed it. And the code will be available in GitHub in case you need help or like you just want to take a look at it. So see you soon.